This Centrifugal Pump Minute, we will be covering best efficiency point and discussing why it is a good target for efficient pump operation. My name is James Farley, and I'm the Griswold Product Manager. Pump efficiency is calculated based on head, flow, specific gravity, and horsepower. Today we're talking specifically about best efficiency point, or BEP. This is the point at which the pump's performing at the highest efficiency level. On a performance curve, you can find best efficiency point by looking for the point at which the pump has the highest efficiency. This is typically towards the middle or sometimes a little bit to the right of a performance curve. This point defines the flow on this axis and the head on the vertical axis that the pump should be operating at to be most efficient. We're now going to look at the pump's actual performance on our test lab to show how we calculate efficiency, and then show how the efficiency changes as you move off of the best efficiency point. Right now, in our test lab, this pump is operating at 480 gallons per minute. So this is very close to our best efficiency point. The total differential pressure is measured at 19 psi, and that converts to about 49 feet of head. We then are measuring RPM and torque, and this calculates a horsepower of around 8 horsepower. Using this information, we're able to calculate this pump as if it's operating near 70% efficient. And that is what you're seeing on this performance curve. We're now going to change the pump's performance and have it operate further to the right of the curve at a higher flow rate and show what happens to efficiency. So we have now increased the pump's flow rate from the best efficiency flow out to the right of the curve, and you can see we're now operating at around 660 gallons per minute. At this flow, our differential pressure is 9.7 psi, which is equivalent to 27 feet of head, and our power consumption is 8.6 horsepower. If you use this data and you calculate pump efficiency, now the pump is operating at 52% efficient, which is expected now that we're operating at a higher flow and our efficiency has dropped. Next, we're going to decrease the pump's flow rate and see what happens as we're closer to the left of the curve. Now the pump is operating at around 190 gallons per minute. As you can see, that point is well to the left of the performance curve, and we would expect the head pressure to go up and the power to go down. We're now operating at around 26 psi differential, which is close to 61 feet of head, and our power consumption is calculated at around 5.9 horsepower. Using this data, our efficiency is now about 50% efficient. What you're going to see is we had low efficiency at the left of the curve, high efficiency at our BEP, and again lower efficiency as we moved to the right of the curve. So what we have demonstrated is that the pump efficiency dramatically changes depending on where you're operating the pump on the performance curve. To optimize your system performance, you need to select and operate a pump near the best efficiency point. I hope you found that helpful for sizing your pump. Thanks for joining today's Centrifugal Pump Minute.